Welcome everyone. I'm Kamesh from CAC first year in Janssens Institute of Technology. Today I'm going to explain the applications of mathematics in gaming theory. Synopsis. In this, we are going to discuss about introduction, classification of games, game theory, examples in real life, cooperative versus non-cooperative games, and conclusion. First, introduction. Game theory branch of applied mathematics and that provides tools for analyzing situations in which parties called players make decisions that are interdependent in interpretant. The interpretants causes each player to consider the other player's possible decisions or strategies in formulating strategy. A solution to a game describes the optimal decisions of the players who may have similar, opposed, or mixed interests, and the outcomes that may result from this decision. Although game theory can be and has been used to analyze parlor games, its applications are much broader. In fact, game theory was originally developed by the Hungarian born American mathematicians John von Neumann and his Princeton University College Oscar Morgenstern. And the classification of games. Games can be classified according to certain significant features, the most obvious of which is the number of players. Thus, a game can be designed a being of one person, two person, or n person with n greater than two. Game with games in each category having their own distinctive features. In addition, a player need not be an individual, it may be a nation, a corporation, or a team comprising many people with shared interests. In games of imperfect information, such as chess, each player knows everything about the game at all time. Poker, on the other hand, is an example of a game of imperfect information because players do not know all of their opponent's card. So the first image is called chess and second image is called poker. The extent to which the goal of the players coincide is another basis for classifying games. Constant sum games are games of total conflict, which are also called game of pure competition. Poker, for example, is a constant sum games because the combined wealth of the players remains constant, though its distribution shift in the course of play. Players in constant sums games have completely opposed interest, whereas in variable sums game they may all be winners or losers in a labor management dispute. For example, the two parties certainly have some conflicting interest, but both will benefit if a strike is awaited. Finally, a game is said to be a finite when each player has a finite number of options. The number of players is finite, and the game cannot go on indefinitely. Just checkers, poker, and most parlor games are finite. Infinite games are more so subtle and will only be touched upon in this article. A game can be described in one of three ways: in extensive, normal, or characteristic function form. Sometimes these forms are combined or described in the section theory of Moore. Most parlor games, which progress step by step, one move at a time, can be can be modeled as game in extensive form. Extensive form games can be described as game tree, in which each turn is a vertex of the tree, with each branch including the player's successive choices. Game theory examples in real life. Game theory is an interesting subject and one that can be applied to every day. There are many examples in today's world that will show you how game theory works, for good or bad. According to experts, these are some real life examples where people use this strategy successfully or not so much. Game theory's real power is in its ability to analyze incentives and decision making. Statistical analysis and traditional economics and game theory operates in space between these two extremes of analyzing the choices people are likely to make in given situation. One of the most useful applications of game theory is in politics. Political parties in the United States are rarely a perfect match for a given voter's political preference. So it can also be applied to the behavior of candidates and political parties themselves. And second one is predict of the behavior of consumers and investors in any number of fields. Game theory can also be a great predictor of the behavior of consumers and investors in any number of fields in my line of work. Higher education choices are a great example. The more people post college degree, the less value these degrees has a single of for grade lines. We came to cooperative versus non-cooperative games. Communications is pointless in constant sum games because there is no possibility of mutual gain from cooperating. In variable sum games, on the other hand, the ability to communicate, the degree of communications, and even the order in which players communicate can have a profound influence on the outcome. In a cooperative game, however, A can threaten to play 2 unless B agree to play. If and second one, if B is payoff will be reduced to 3 while A's payoff will rise to 4 at 4, 3. If B doesn't agree and A carries out in threat, A will neither gain or nor lose at 3, 2 compared to 3, 4. So this is our cooperative games. And sequential and simultaneous duels. As an example of n-person non-cooperative games, imagine three players A, B, and C situated at the corners of an equilateral triangle. They engage in a duel or three-persons duel in which each player has a gun with one bullet. Assume that each player is perfect shot and can kill another player at any time. There is no fixed order of play, but any shooting that occurs in sequential, no player fires at the same time as in any order. Consequently, if a bullet is fired, the result are known to all players before another bullet is fixed. Thus, thinking ahead about the unpleasant consequences of shooting first of colluding with another player, so to do so, nobody will shoot or collude. So we came to the conclusion. Theoretically, n-person games in which the players are not allowed to communicate and make binding agreement are not fundamentally different from two-person non-cooperative games. In the two examples that follow, each involving three players, one look for Nash equilibria, that is, stable outcomes from which one no player would normally depart, because to do so would be so disadvantageous. Mathematics is used in each and every real-time applications, not only in gaming theory as well as in prediction, rocket launching, etc. Thank you, guys.